It's Mr. Van Hong here with week 6, day 1, distance learning for math. And today we are traveling to another dimension. So everything you've done in math up until this point, for the most part, has been either one-dimensional or two-dimensional. And today we're going 3D, which is the world that you live in all time. So real quick, let's talk about what when we talk about dimensions, what it is that we're talking about. So when we talk about like something that is 1D, one-dimensional, it means that you can only measure it in one way, like length, the length of a line. A single line just has one measurement. It's left and right, and there's that one dimension that it exists in. If I wanted to put a dot on this line, it can just go in left and right order. There's the number line. That's it. So it's one-dimensional. If I'm going to make something that is two-dimensional, it means that there are two measurements. There's left and right, and there's up and down. So bam, look, now it's 2D. Something that's 2D, an example of something that we can easily imagine being two-dimensional is a piece of paper, right? There's a bunch of different places on this paper where I could put a dot. Thinking about left and right and up and down. If you've ever played the game Battleship, Battleship is a good example of measurements in two-dimensional space, right? You always have to say what row and what column you're firing out. You could play Battleship in one dimension and you would only have to pick the column. That's a good way maybe of trying to visualize the difference between one-dimensional and two-dimensional. One-dimensional Battleship, you would just be like, I fire at row A. It's a hit because there's only one place to fire at, so it's it. So you need two dimensions to play Battleship. All right, so 3 dimensions means that there's a third measurement. And if I'm going to try to represent, now this board is flat, right? This is a flat surface. This is a two-dimensional surface. So I can't actually like grab this and pull it out and make it 3D. That'd be cool. It'd be a neat special effect. So I'm going to make an optical illusion to make it look 3D. So tell your brain that this is now a 3-dimensional object where this part of the arrow is closer to you and this part of the arrow is further away. And now we can imagine a physical space in which something like this could exist, okay? So where, I guess maybe I should have done all of them like this. Pretend, these are all actually 3-dimensional objects, but pretend that this just had up and down. That's it, one dimension, okay? 2-dimensional, it's got up and down and we've added left and right. And then 3-dimensional, it's got up, down, left, and right, and it also has depth. It has forward and backwards, which is what this arrow here represents, that forward and backwards aspect of that. So we are in the 3rd dimension now in math, which is pretty cool. What we're going to be doing today is folding paper and answering questions about the paper that we fold, kind of describing it and that sort of thing. It's the type of figures we're making today are called rectangular prisms. A rectangular prism is when you take something that would count as a rectangle like this. Mr. Van Hong, that's a square. Squares are rectangles. So this is a rectangle. If I could grab this and stretch it out so it was bigger, look, I did it. Now it's like that and it changed colors. I stretched it out. That's what a prism is. A prism is when you take a shape and then stretch it out into the 3rd dimension. So a rectangular prism, your base shape is always some sort of a rectangle. Stretch it into the 3rd dimension, and now you've got that. So I've got here's a rectangle, right? That sheet of paper I had earlier, and I'm going to stretch it out into the 3rd dimension. Now it's a whole bunch of these pieces of paper, and this makes a rectangular prism. The base is still a rectangle, but now I've added some depth to it or some height, depending on how you want to describe it. So that's what the 3rd dimension is. All right. Now, what we're going to be doing is building 3D figures, and you should have received in your packet, I'm pretty sure I counted correctly, it should be 6 of these. You have exactly the right number of these for this assignment, including your homework tonight. So if you make a mistake, maybe tape it back together or something. But you probably, there's not a lot of, it's not a big deal if you screw it up and can't do one of the problems, but be careful when you're using these, because what we're going to be doing is tracing shapes and then cutting them out and then folding them, which should be pretty cool. So let's turn to page 935 in your math book. And we can see that they're talking about what I was talking about, 3D figures. They also use a word called a net. A net is a two-dimensional pattern of a three-dimensional figure. And so this down here is an example of a net. So this is the two-dimensional pattern of something that could be folded into the third dimension. So we'll be doing that. It talks about a special word for, there's a particular type of rectangular prism called a cube. So a cube, much like a square is a rectangle, a cube is a rectangular prism. This cube is a special type of rectangular prism. It's called a cube because all of its, because its base shape is a square, is one way to think about it. The only other vocab word we have today is a face. Mind your face. The face is just, if you were going to draw a face on a 3D object, the face is where you would draw the face. There's three special words that we're going to use. We're going to focus on those words tomorrow. Three special vocab words when we're describing the parts of a rectangular prism. Face is one of them. Face is where you would draw a face if you were going to draw a face on your 3D figure. The big flat two-dimensional area. Okay. You are now going to, at the bottom of the page, it says to copy down that pattern. So count how many squares. You need to make a little plan and trace it. You don't need to do it in pen or anything like that. So if you make a mistake, you can erase it. It's pretty flimsy paper, so if you're erasing, be careful. And then once you've got it copied down, cut out around it, just that, like the perimeter. Don't cut right there, right? Cut around the perimeter of the object, and then join me again. So you're going to pause, and then you're going to copy down the net, and then cut it out. Okay? All right. Do that now. All right, welcome back. So you should have this. This is the net in 2 dimensions now. So just like that, I've cut around the perimeter, and I did trace in the other. You can see the same shape repeating over and over again, right? That shape is a square that's repeating over and over again. So guess what is going to happen when we fold it? So it says to fold along the lines to form a 3-dimensional figure. So let's fold along the lines. So this line right here, fold. Now, when it says fold, it's not super clear. It doesn't mean like fold and then like leave it there forever. We're going to fold it and make like right angles with it. So make all the folds real quick. Paper is not the sturdiest ever, so be gentle with it. Okay, so now I've got all of my folds, and I kind of fold it up into, it made a cube. All right, so I've got a cube now. Cool. If you've got tape, you can tape it up if you want to. You don't have to. I'm not going to tape this one up. Go ahead and turn the page, and let's answer some questions about what we see on this cube. Never mind, there are no questions on that side. I'm just going to ask you some questions about it. How many faces does it have? How many faces are on this cube? A lot of kids go 4 because it's a square, and they're used to squares having 4 of everything. It doesn't have 4 faces. Count carefully. The way that I like to count the faces of any rectangular prism is I count the ones that I think of as being on the outside first, and then I count the top and the bottom. So, or any prism in general, whether it's rectangular or not. So how many faces does this have? Well, there's 1, 2, 3, 4, 5, and 6. So there's 4 on the outside, and then 1 on the top and 1 on the bottom for 6 faces. So this has 6 faces, which will be an important part of what we're talking about tomorrow. We'll also be using other vocab words to talk about the other pieces of the other special words and basically classifying prisms. So this is a cube. We made a cube. That's so cool. All right. I am going to have you turn the page, and then you can see here, remember you've got 5 of those sheets. You have enough to make this one and answer the questions. This is that cube that we just made. It says 5 units on it. Did you notice that this is 5 units? It's 5 units. Every unit in this, it says unit because we could have given you different sized grid paper. This grid paper, every unit is 1/2 inch. It doesn't matter, but it is. So you can answer the questions about the cube when it's talking about how many faces are congruent. Congruent just means exactly equal. Fancy word for exactly equal. So how many of the 6 faces on the cube are congruent. They all are. They're all the same, right? It's a square, and then the whole thing, because it's a cube, all 6 are congruent. But in other shapes, in other rectangular prisms, it won't all be congruent. So watch for that on some of these other things. All right, so you're going to make these other shapes. You're going to draw the nets just like we did in that previous example. You're going to fold them up. You're going to answer the questions about what two-dimensional figure forms the faces of the figure. What is the shape of each face on the figure, and how many congruent faces are there, and all of these other things. And then same thing on the back. And then you've got extra grid paper so that you can do both the example net on the homework for tonight, as well as the net on the back side too. Well, actually, a note about the one on the back side. I'm going to give you the paper. You're going to have an extra sheet of paper, but if you look very carefully, that appears to be the same as this one. It's the same that we just did. So you can make your own maybe, or something like that. If you don't make any mistakes, you should have an extra sheet of paper of grid paper, and maybe make your own for fun or something like that. Alrighty, that's the third dimension: building 3D figures, folding paper, building spatial awareness, answering questions about it. Tomorrow we'll classify them. All right, miss you guys. Talk to you later.